In our previous examples and videos, we've seen something like this, where we declare some variables, maybe initializing them with a value, and then we print out that information, or we use it in some other way. When we've worked on our previous applications, we might have run into an error, and that error will say something like having an issue with the L value. You might have always wondered, what is the L value of a variable? Well, the L value of the variable is the value that you see that you use. But a variable actually has two parts to it. The variable is the value that is stored, but is also a memory location where that information is stored. In a language like C and C++, that becomes pretty important. In some languages like Python and Java, that information is hidden from the developer. But we need to be able to access it in C. It's a little bit more low level, requires a little bit more work on our part, but it allows us to be more efficient and faster. And that's why C and C++ is still used in developing operating systems and system level applications, because it doesn't take as much memory and it's faster than a lot of other languages. So let's look at how we can create what's known as a pointer, which points to a memory location, or a variable in this case. So you'll see here that I've created 3 new variables. After each data type, I've put a star. This is what lets us know that it's a pointer. I've also used a P in front of the variable name. That way, I know instinctively when I'm looking at my variable name that I'm dealing with a pointer to that variable and not the variable name itself. Now, when we get into more complicated versions of pointers, we're going to create this and store it inside the pointer location, never giving it an object name. But that's for later on. Let's look at how we're going to initialize these values. So if I want to initialize these values, you can see something like pcount is going to equal, and I use the ampersand to reference that location. What location am I referencing? The variable count. I can do this also with pname and pradius. Now we're storing the variable location in these pointers. So if I go and I print out what that information is, it's going to look a little different. So here I'm printing out the values of my pointers. In our first section, I see the value of my variables, but in my second section, I see the memory address of it. Well, that makes it very helpful to use, but I need to dereference it so I know the value stored in there. Luckily, I can also do this with just a minor change. So what I'm going to do is just add a little space so I can see a difference here. And dereference my variable. If we look at our output right next to our code, we can see in the first 3 print lines, what we do is we print out the values of our variables. In our next 3 print lines, what we've done is we're printing out the memory location, and then we print the value next to it. So this is both sides of the variable. The memory location where the variable is stored, and then the data inside of it. Using a star, we can dereference the memory address and get the value stored within it. And this is going to be very important whenever we're going to work with pointers. We always want to be able to get access to the data stored at that location. This is not completely unique to C and C++, but this is the way C++ handles it. Use a star to define as a pointer, the ampersand to get the reference of an existing variable, and then if you need to dereference it to know the information stored at that location, we use a star associated with the pointer name again. Now, one thing you might have asked yourself is how come it doesn't specify that it's just a pointer data type? It's the data type with a star at the end. Well, that's because it needs to know how big a space it's looking at in memory. Not just that it's looking at a memory address, but what type of space is there? Is it just for a few bytes or a whole, or for a string or a complex object? And that's why we always have to define what the memory type is that we're showing.